Yeah.
All right, buddy. So we're still obviously on this philosophy and science unit, same readings, and we're going to be going through some content that is kind of supplementals. As I said before, I'm not assigning these as required readings, but they cover some interesting material. I picked out readings for the next unit, but I'm still trying to figure out the pacing that I want. But also, you've got to take home the sun's out Friday, so I'm not expecting you to read anything for Monday's class. But just know that they'll be posted soon. Oh, one more thing. So a number of people have asked questions about the most recent homework. In the key, I'm going to try to make sure that as many of those are answered as possible. I might post an announcement too, just to make sure there's still stuff that's unclear to clarify that. And please let me know if that does not clarify things. I'm perfectly willing to go back to it and make sure that there's still no confusion.
One thing I was confused about is the hypothesis. I was wondering if you could talk to that. I tried to email you about it, and I emailed Austin this morning. But
yeah, I did see it. I didn't have time to answer it. The short version, and I'll elaborate on this in the key, is that there's no one answer for how to define a family. It is a little bit ambiguous. You have to be able to make a reasonable argument. Some rules of thumb are that usually people will accept that interactions and main effects are separate families. The conceptual question that you're asking is, do these hypotheses bear on one single question? Is it like one question that's spread out among multiple tests? Does that help?
Yeah, I think so. I was just a little confused about how to bring the interaction in with the contrast code, based on that.
I'll look back at your question and see if it's answered in the key. Okay. We might come back to it on Monday.
Okay, that was most of my questions.
Okay. Yeah. All right, so we're going to do something different for this class. I think philosophy of science is something that works best. I mean, it's not useful unless it's applied. So I'd like you to answer these questions in your small groups. I'll give you, let's say 10 minutes. I'll be monitoring to see how the discussion is going. And briefly, I want you to use whatever paper it is that you found in your groups. Each person should discuss one, what is the theory, and try to be brief. I know that can be hard, but try to strip it down to its essence. Two, what would count as evidence for the theory, and or evidence against the theory rather. And specifically, you should think about is there a lot of evidence that you can gather to refute the theory, or very little. And then lastly, did the scientists who wrote the paper conduct a type of test that's severe that had a good chance of refuting the theory if the theory is actually false? So 10 minutes, I'll monitor and circle back up and stuff. Good.
So it's basically just
Yeah, they use like internet, they,
Interesting. Oh, that's like, when you say yes, because I can hear it.
Yeah. I guess the day-to-day was
What does one teach?
The article that we're tracking was was talking about mainly
So there's those questions here, but it's also, basically it's like, it has to be your own brand, like what can you all choose? So you have like a remember, so like you remember that specific, which I don't know, like choose from, right? So like, I don't know if you've ever like a DR, where like you say like pain, and you say joy, and you say like a bunch of these like, yeah. Yes, no, exactly those, but they're like, so say like everything's like, you'll take right, pain, glass, things like that, right? So, and as you remember window, that would be just like your garage, so that makes sense. The only thing I so, and
it was, I mean,
and there's another process series and
So there's two theories out there.
it's basically they just there's not a way about it. It's kind of like Freud, like even if you say that it's not even that trace I usually upset. And so I don't think that there is a way to because the other people they're like, well, but they're just and so I that's all. It's just really yes. I don't like it, but also when there are views so my kids like
Yeah.
no, and there has been a lot of sports and there's been just as much as which is why people also like automatic. I think that's like the frustrating part is that you can't necessarily qualify because you don't know for real since all the behavioral problems. It's not necessarily using that.
So it's
Not as much, but it, I think it has to do with like, it's like one of the distribution instead of like two memory. And so that's why I kind of like, I like the fuzzy trace theory, but I don't know, it doesn't help a lot. And so their tests, like they do tests and it's fine, but like,
That's what they do.
they're the big ones that find support for their own research. And so, yeah, no, so it is definitely, it's been decided showing, it's just not for me. But they also like in every conference. Like, I can ask that question. No. You tell me. But yeah, so it's just been, you know, for like a lot. It's just not the best theory, but it is. Right? Well, you might just say it's I mean, she's excited.
Yeah, I think in this area, they got.
Which
I don't have patience for that.
Here comes this guy that shows that no, there are 49 parties.
You just said something you're gonna
To
do.
the theory that was distributed, right? How it's distributed, it was good for electric, right?
So it's like how hard you
Demonstrates that.
And also like the first one. So what was the?
And another thing is, like travel size, it even shows it was on size, like travel size. And which he like revolutionary, he demonstrated
Well, I think that's.
in
Impossible task. No, I agree. And also, I think it's a fine line towards like not. But you really hurt yourself. Everyone knows like. Because I feel like it's not safe.
So they
So maybe it is.
no, they yeah, it was kind of they didn't have.
Yeah, they should have, I'm just saying. So that doesn't travel in race days, it also.
Yeah.
We have to see reviews of the videos we saw, was not
Oh, I haven't opened one.
Yeah.
All right, wrap up your conversations. Before we do, I'm going to ask some of you to like report out on what you thought, how does this evidence that might falsify the theory and why the test was severe. Before we do that though, a couple quick questions. For the papers that you found, how many of you were able to identify evidence that could refute the theory? Raise your hand.
Like theoretically,
Was it always easy to identify that evidence? How many people thought that it was easy to identify that evidence? Okay, next. How many people thought that the paper that you found put the theory to a severe test? Raise your hand. One person. I'm going to ask you about that in just a bit. How many of the papers that you found actually provided evidence against the theory? Two maybes. That's very interesting. All right, can you tell me what was the severe test that you found?
It was like this big experiment called the photoelectric effect. So my theory was the classical representation of light as a wave, but the scientists hypothesized that maybe light has other properties besides wave-like properties, and so the severe test was this robust experiment that other scientists worked on and built upon. So they did an actual this small experiment where they have a metal surface, some wires attached to this device and measures current, and they shine light on the surface, which they saw that it ejects electrons when light hits it. And then Einstein and other scientists built on that work, and they eventually saw that light has particle properties to it, not just wave light. And so they just did a lot of work that they eventually came up with another branch of physics that refuted classical physics, which had that classical representation of light.
That's great. So one thing I'm noticing, this is an example from outside of the social sciences. To come back to that idea though. So what about it, in your opinion, made this test severe?
So I think it's a matter of just technological advancement in the time, because they didn't have the equipment to really do anything else to test light. So I think it's just a matter of technology was up to par at the time, and they realized that to show these cool things about it.
So that's great. Well, I'm going to help you out just a bit. One thing I'm noticing about that experiment is that the scientists are trying to prove themselves wrong.
Right. Yeah.
In fact, they're looking for something that, if they find it, that's going to be taken as strong evidence against classical mechanics. So, from a non-expert point of view, that's one thing I think that would make that example severe. It's a great example. All right. So the rest of you, it sounds like, covered papers that were not doing severe tests. Can someone give me an example of a test that they thought was not severe? Well, let's go to this table. So someone from this table, name a test that you thought was not severe.
Well, for mine, they did a series of 5 different experiments, and their sample sizes ranged from 11 to 16 people per test and per experiment. And I don't know if that's a very decent sample size for the type of studies that they were doing.
So, yeah.
But they did have decent effect sizes.
Yeah, so low sample sizes are something that can either make your test severe or not. It's an interesting paradox I'm going to talk about later in this lecture, where there are some circumstances under which, if you have a large sample size, actually your test is going to be really not severe. It's a matter of what you're. I'll get to that idea in a bit, but I want to plant that seed in your mind that in some cases, very large studies can actually be doing tests that are really not severe.
Right. Yeah.
So,
That's what we're talking about.
okay, great. Well, hold that thought. We'll come back to it in a bit. So, multiple studies. it sounds like they found large effect sizes, or they reported large effect sizes. Sample sizes were low. Cool. Mid-table order. Or, so they would test that was not severe, that they thought was not severe.
With my article that I found, it was basically a study determining the association between food acceptance and depressive symptoms. And their criteria was just that there would be a negative relation between a few variables. So a higher level of food acceptance would result in lower level of depressive symptoms. And so if we're using a definition of severe test, like we had an example yesterday where it specified a specific magnitude, then it would not be severe. Whereas they just specified directionality.
And I assume they were testing against the null hypothesis of zero.
I believe so.
Okay, great example. So direction, prediction, test against zero. Great. One more example from over here. So they would test that was not severe.
So I had a study, it was a fMRI study, so I thought the fact that they used the FORC, they were trying to find the neural basis of reactive aggression. So I think the fMRI was probably severe, but they only had to have a really small sample size, so I wouldn't imagine it wasn't. And they threw out basically anybody whose fMRI didn't pass.
So what about the use of fMRI would make the test severe?
I just think that it can capture something that just behavioral testing can't. So they were trying to add to the general aggression theory that exactly the general aggression model that has personal situational variables that contribute to aggressive behavior. So they wanted to add another dimension to that was not just behavioral data. So I thought that was cool.
Yeah, so that's something that might be new, looking at a different domain.
Mm-hmm.
But the idea behind severity is that you're putting your theory at risk, grave risk of reputation. So what about the use of fMRI that puts the theory at great risk of reputation?
So the theory said that there are personal variables that contribute to the aggression. So if the fMRI shows that everybody has kind of the same activation, I think it could put their theory at risk. There's some sort of really specific, like personal areas that relate to aggression.
I could imagine though that maybe they'd say, well, this isn't something that shows up on brain activation. It might show up in other ways, like maybe if you did an EEG study, it would show up there.
Yeah.
I guess it depends on how they framed it in the paper and what their logic was. But this is an important idea. Just using a new measure doesn't necessarily make a test severe. If they're willing to go to the extra distance to say, well, we don't find it in whatever this measure is in the fMRI measure, we're going to doubt the behavioral data. If they're willing to go that extra mile, yeah, it sounds like maybe there's something severe about this, or more severe. So that's an interesting case because I can see it going either way. Cool. So going back to this idea, it sounded like it was, you could in principle find evidence for most of these theories that might put them at risk of reputation, but a lot of the studies weren't actually doing that, or at least they weren't doing that in a way that actually took the risk. That's an important idea. And I also find it interesting that the one instance of the test that was severe was in physics, where I'm not sure if this was always the case, but currently there is this tradition of going out to like actually find that evidence or look for it using precise measurements. And if you find the evidence that using those precise measurements, they're going to say that the theory is wrong and needs numbers. That's not as much the case in the social sciences. So I showed you this graph last semester. I don't know if you remember it, but it came up during the meta science unit. This researcher, Danielle Pinelli, just looked through a bunch of papers and tabulated how many of those papers say that they got support for their main hypothesis, for the research hypothesis. So this is a figure of the percentage of studies that say that they found support for the main hypothesis. And right at the bottom here is psychology. So about 90% as of the study, 90% of studies in psychology said that they found support for their main hypothesis. At the time, a couple of the things that we talked about as being a potential cause of this, it seems kind of unlikely that psychological theories exist enough that we're really right all the time. So at the time, a couple of the reasons that I described that might be causing this are things like publication bias. So when you submit to journals, there's this preference for publishing positive results. And likewise, when scientists submit to journals, they tend to like to submit data that show that support, and they don't like to submit the data that doesn't show that support as well.
So is that not the case for the other sciences then, or less so the case?
Yeah, that's a great point. So that would explain, something like publication bias would explain why, in general, this is 50% right here. So in general, across these fields, more than 50% of the studies claim support for the research hypothesis. It would not explain what makes psychology different from these other fields. That's a great point. So we're going to talk about that. What is it about social science that makes it hard to do severe tests? There are a bunch of factors that might be at play, and I don't know that we have a direct answer to this question. But we have some ideas about what might be especially hard in social sciences. And I'm going to be drawing a lot from the writings of a political psychologist named Paul Meehl. His writings, his papers are, I think, really amazing and very insightful, but sometimes a little bit difficult to slide through. If you're interested in reading more, and Paul Meehl's papers are definitely worth a read, I suggest these three, in addition to the one that I assigned as required reading. And all of them are posted on Paul Meehl's website. He's stepped down, but it's maintained as a repository of his writings. So one idea to help ground this discussion is often scientific theories have a certain structure. So there are some ideas that are often on the periphery. This set of ideas are often called the protective belt. And they're not quite as central to the idea, to the theory at hand, but they're still necessary or related to some of the central concepts in the theory. More core to the theory is this set of ideas at the center that are sort of holding it up. There may be the things that scientists are most interested in. I'll give you some concrete examples of what these are in just a bit. But the basic idea here is that often theories have this sort of structure with a hard core at the center and a protective belt, a set of peripheral ideas on the outside. And another important idea about the structure of theories is that usually the ideas that are on the periphery of the theory are easier to refute or falsify. It's easier to find evidence that would be contrary to those ideas. Whereas at the ideas at the core, sometimes they're so general, they can mean so many different things that it's pretty hard to provide evidence that directly refutes those ideas. There are some special names for these more central core ideas and the ideas that are at the periphery. In psychology, you sometimes hear the word framework. like evolutionary psychology uses the framework of natural selection. You also sometimes hear the word perspective, sort of this idea that there's a broad perspective that you apply to a bunch of different domains. You sometimes hear just the word theory used to mean this like hardcore ideas, although sometimes theory is used to mean the stuff on the outside too. It's a little bit confusing. Some terms that you hear for these ideas that are at the periphery are things like auxiliary theories, hypotheses, or theories of measurement. These are necessary to make the theory go, and they might be connected in some logical way to the ideas at the center. But they're not as central to the ideas that scientists who are working on these theories are interested in. So to give you an example of what this looks like, we'll go back to this example of snakes and trying to figure out whether snakes are land dwelling. If I find a counterexample to this hypothesis that snakes are land dwelling, the hypothesis is immediately a threat. This is an idea that probably is going to be on the periphery. It might be something that I test in order to learn about something a little bit more general than I'm actually interested in. A theory that might be at the hardcore, or an idea that might be at the hardcore of the hypothesis that snakes are land dwelling might be something like reptiles are land dwelling due to the fact that they have cold blood. So it might be harder to regulate your temperature when you're in water. This might be a functional reason why snakes are land dwelling. There's not like a hard and fast rule for what's going to count as the hardcore and what's going to count as a peripheral idea. But over the course of reading the paper and seeing how a theory is described, often you can draw your own conclusion about what's like a little bit more general and taking this central role in this particular paper. But it's like harder to prove that wrong than what's actually tested with the paper. Usually the ideas that are actually tested in the paper are some of those peripheral ideas, things at the protective belts, whereas the like grand thing that the scientists are interested in, they might develop over the course of their career, that's going to be more of the thing at the hardcore. So another thing to notice is that it's easier to refute this idea that snakes are land dwelling than this idea that reptiles in general are land dwelling due to cold-bloodedness. Because, it could be, for example, that green anacondas are not cold-blooded, or there could be any number of reasons why green anacondas are like weird or different in a way that makes them not bear on this idea that the reason that reptiles are land dwelling has to do with cold-bloodedness. So to kind of fill in the blanks here, this idea of providing a reason for cold-bloodedness, that's something that you might put at the hardcore. The hypothesis that's actually tested by a specific study of like going out and observing where reptiles live, that's going to be at the periphery. But there's also another set of ideas that's like necessary for this theory to work. So there are certain assumptions that connect the ideas at the hardcore to the ideas at the periphery, that connect the theory or the perspective or whatever to the hypothesis. Those assumptions might be things like snakes are reptiles are cold-blooded, and there's a certain way, a certain definition of cold-bloodedness, maybe a certain way of testing for cold-bloodedness. All these are ideas, sometimes called auxiliary theories or auxiliaries, that connect a given hardcore idea to something at the periphery. And likewise, if you actually go out and do a study, you need certain ideas that connect things that you measure to the concepts that you're actually interested in. So one of those theories of measurement, ideas of why a certain measurement is valid, they might be things like, if an animal lives 60% of its life on land, it's land dwelling, it's a certain way of diagnosing land dwellingness. Or if an animal's temperature matches that of its environment, 70% of the time it's cold-blooded. So basic idea here, you have ideas that are more central, ideas at the edge, and you have a certain set of assumptions that connect both the ideas at the center to the ideas at the edge, and the ideas at the edge to the things that you actually know. And that all together is the thing that forms the theory, the set of ideas that constitute the theory. So theories actually have a pretty complicated structure. So if you find evidence that might serve as a refutation, you could reasonably ask the question, well, what has actually been refuted in this theory? Might not be the thing at the hardcore, because there could be all sorts of like weird things that happen at the periphery that explain why this refutation happened. So it could be that my measurement of land dwellingness was flawed, or my measurement of cold-bloodedness was flawed. Or it could be that some snakes are not actually reptiles, and I happen to find one of those snakes that is not a reptile. It could even be that the hypothesis that I tested is refuted, but that doesn't necessarily mean that everything about the theory at the hardcore is refuted. So the fact that there are some things that are, some ideas that are more prone to falsification than others makes it so that the stuff at the hardcore almost protects the ideas at the center from contrary evidence. That's just part of how science works. It's not like necessarily a bad thing. You might not want to give up on a general idea just because it didn't survive one test. But it does mean that theories have this sort of natural resistance to falsification. And that's one of the tough things about being a scientist. Okay, so that's one like hypothetical example. Here's another example that has actually happened in psychology. So it might connect to something that you're reading if you're like in a class about social psychology. There's some good popular press pieces on this specific case that you can go and look up if you're interested. Actually, I'll post some links on Blackboard. I don't have them now, but if you're interested, it's a good case study of these ideas in action. So there's this idea in psychology of embodiment. This is one definition of embodiment. It's just the idea that stuff about the body affects thought. So whatever's happening to your body, that is probably going to bear some or have some positive influence on the things that you're thinking of. This is something, an idea that's stated very generally. And so I'm trying to identify ideas at the hardcore. One thing to look for is that they're stated very generally. One example of embodied cognition, is the facial feedback hypothesis. So the idea of facial feedback is that stuff that's happening to your face, specifically facial expressions, influence emotions and behavior that's connected to those emotions. we've got one idea that's at the hardcore, that's at the center of the theory, and one idea that's on the periphery. A lot of introductory psychology textbooks, if you took an introductory psychology class, maybe you read about it. The idea behind this is that, or what they did in this paper is they asked participants to rate how funny Far Side cartoons were. And the twist was that the participants either held the pen that they used to rate the cartoons using an expression like this. Specifically, they were told, don't put your lips on the pen. Or they rated the cartoons like this. So the idea is that if you've got your lips extended, it's kind of like a smile. That's one of those aspects of your body that might influence your emotions. If you're kind of making an expression like a smile, you might make the cartoons funny. And the reverse is true if your lips are touching the pen. That's supposed to be like a pouting expression. In this first paper, they found data that looked kind of like this. Generally, it seemed like the participants who rated the cartoons with that smiling expression thought the cartoons were funnier than when they had this pouting expression. So I want to point out here that in order to connect this specific set of evidence to other aspects of the theory, we need a lot of auxiliaries. So one of those might be that humorousness is affected by whether you're smiling or you're pouting. That's not stated directly in this hypothesis, but there's this sort of supportive idea that connects the idea of embodiment to the idea of facial feedback. There are also a number of sort of meta theories about what you're actually doing in the study to help connect what's happening in the study to facial feedback and therefore to embodiment. So one is that if you circle a number from 1 to 7 about how funny a cartoon is, that act of circling that number captures feelings of humorousness. That's an assumption that is necessary to connect what's happening in the study to the theory. Another idea is that Far Side cartoons are similar to other cartoons. Another one might be that the act of putting your lips to the pen or separating your lips from the pen actually induces a facial expression that's kind of like smiling or pouting. These are just some of the assumptions. I'm just listing these for illustration. But notice how what's happening in the study is quite different from the central ideas that the researchers are actually interested in. And there's certain meta theories, assumptions, or whatever you want to call them, things that are in that protective belt that are necessary to connect the evidence in the study, the observations, to the hypothesis, and also to connect the hypothesis to the hardcore. So one of the things that's been happening, particularly in social psychology, but in psychology in general, is a lot of people are becoming more interested in doing old classic studies again to see if they produce the same results. One of those was was called a registered replication report. Basic idea is you get a bunch of labs to sign on board to do the study again and see if you get the same results. One thing that I'll mention that will come up a little bit later is that the participants were filmed at each of the sites. This was to check on one of those assumptions that putting your lips to the pen induces an expression that's kind of like pouting, and separating them induces an expression that's kind of like smiling. So they want to make sure that that was true. And this is what they found. So at the top are the original results from that first paper that I talked about. These are the results from all the different labs. This is the test against zero, and yeah, they found no difference in funniness ratings from the smiling, between smiling and the power conditions.
Maybe people are hard to please now, we're in 98.
Well, yeah, so that's an important idea. Going back to this idea of things that are at the periphery and things that are at the center. If we do accept this as a refutation of something, you have the natural question, what is it a refutation of? Well, is it the case that, is it truly the case that humorousness is affected by smiling versus pouting? If that's not the case, maybe this hypothesis hasn't actually been refuted. Maybe some other way of inducing facial feedback would do a better job. The measurements of the So it might not be that our Likert scale is actually capturing humorousness. Could be that there's something weird about the cartoons, if we need funnier cartoons. Logically, we don't know what we should be refuting here. It actually, if you look at how this debate has progressed, you can see this ambiguity in action. So one of the responses to this registered replication report is, the fact that you filmed these participants was bad. Facial feedback doesn't work, people are being observed. So you included that camera, these results don't actually bear on the facial feedback hypothesis. So actually a paper that came out last year that was trying to suggest this very idea. Here's what they found. I have some technical objections to what they did, but it doesn't really matter for the purpose of the class. What they reported anyway is that if you don't have a camera, you get that difference in funniness ratings, and if you do, the effect goes away. One thing that's you can sort of see in action here too is that it's very easy to add ideas to that protective belt. That process of adding ideas has a special name. I mentioned it on Monday. Anybody remember what that is? You have some extra assumption that is necessary.
Ad hoc addition.
Ad hoc addition, yeah. I would argue that this is an ad hoc addition. The fact that suddenly the cameras really matter to get the facial feedback hypothesis. That's one of my technical objections to this. But I mean, it could be true, right? It could very well be true. And notice how if you add this ad hoc addition, it sort of serves as a sacrificial lamb for the theory. And that's actually true with anything in the protective belt. That's why it's called the protective belt. All these hypotheses, these sort of meta theories that are necessary to connect your hardcore to the hypothesis, all those can serve as sacrificial lambs. They can take the reputation in place of the hypothesis. Notice too that when I've been talking about this idea of the facial feedback hypothesis, at no point has that hardcore embodiment ever been at risk of refutation. That's generally true. It's really hard to refute something that's at the hardcore because it's so general. It means so many different things. It is true that if over time scientists realize, there's a lot of ad hoc additions to save this theory, maybe this theory isn't good anymore. So that sometimes happens. Sometimes scientists give up theories because they cease to be useful. They cease to make good progress. But in general, no single piece of evidence is ever going to refute an idea that's as general as maybe thoughts are shaped by the body. I've already mentioned this, but that in that specific example of the suggestion that hey, maybe the addition of that camera is the thing that messed everything up. While that ad hoc addition is the thing that allows the hypothesis to survive. So even hypotheses that are not quite as general as stuff at the hardcore can also be resistant to refutation because of these extra auxiliaries. One feature that's just generally true of the social sciences is that we need a lot of auxiliaries to make theories work. I've just listed a very brief list of them, but one auxiliary is that all motions are the same. There's not like something necessarily different about any given motion, which is different from neighbor. Another idea is that humor is an emotion. Something that's generally true in the social sciences is that, probably is true that culture affects a lot of different things. We don't know what though. But something that's might be in the protective belt is that this phenomenon is not culture specific. Another thing that's true is that's generally true in the social sciences is that history is pretty important, and so the political context is also important. So that's probably true. We can probably take that as a given, but then if we're trying to test theory, we have to, that's something that can be in that protective belt, an assumption about generality or specificity about theory. One idea that's come up in the facial feedback hypothesis and a lot of these registered replication reports is that in order to get an effect, you need to have a certain level of expertise as a scientific lab. If you're not an expert lab, if you've not been doing this for many years, you're just not going to be able to do it. That's a very easy ad hoc addition. I don't think that has a lot of water, but it is generally true that it's something that can easily be attached to a theory, especially in the social sciences, in order to protect it from refutation. So going back to this question I started with, why is it that it's hard to do severe tests in the social sciences? I'd say one possible answer is that social science theories generally require a lot of auxiliaries to connect the hardcore to a specific hypothesis and then to connect a specific hypothesis to a way of testing. And that structure means that it can be really hard to figure out a way to really put that hypothesis or that theory at risk. What can you do about that? Well, I don't have any one answer that solves this problem because it's part of what makes social science hard. And also interesting, I think. But some things that help are to be explicit ahead of time about what ideas are necessary to make a test work, to make a test informative. It's probably not a good sign if again and again and again, if you're trying to test an idea, you actually do the test and see results that disconfirm your hypothesis, that you're like, oh, I probably did this wrong, or oh, I probably did this wrong. That could be true, but another thing that could be happening is that the hypothesis is false, and it's, you're coming up with one of many, many different auxiliaries to add ad hoc to the result. So sometimes it's rational and good to think about those auxiliaries and falsify those instead of the essential hypothesis. But really consider, is my hypothesis actually false? That's a good question to ask. Another thing that you can do is before you even get to the point of testing a hypothesis that you're interested in, gather evidence that bears on the auxiliary groups. So try to put those auxiliary hypotheses at risk, give them verisimilitude because they survive tests, they survive reputations. And if that's true, then you can probably be sure that if you do a test that is supposed to be important about the hypothesis, that it's the hypothesis that's false, not the auxiliary groups. So gather evidence about your auxiliary groups. Gather evidence about the validity of your measurements. Gather evidence about the assumptions they make. And then the last thing that you can do is explicitly map out the logic that connects the hardcore of your theory to a given hypothesis, and then a hypothesis to a specific test. Because that's a way to figure out what auxiliary assumptions are even necessary and which aren't. Sometimes you think something is necessary, but logically it's not. So that was one potential reason why severe testing is hard in the social sciences. There's another that's, I think, a little bit specific to social science research. And in order to give you a sense of, to give you an intuition of what the problem is, this is just, this is a data set that I collected. It's a large data set, specific hypotheses are really important. It's nationally representative and the sample's large. And one thing that I've done is I've added some color coding to, this is a correlation matrix, a matrix of correlations of some subset of the variables that are in this study. And the red cells are close to -1. The blue cell or the green cells are close to +1. Anything that's white is 0. One thing that might jump out of this correlation matrix is that there's a lot of color. There are a lot of relationships that are non-zero. Because this is a large data set, there's still going to be some sampling error, but these are maybe reasonably close to the population values. One thing I want to point out about this too is that, there may not be any theory or set of theories that explains or is even interested in these correlations. These correlations could just, there's going to be a reason for it, but it might not be a reason that's theoretically interesting. So in general, in the social science, or at least this is an argument that Paul Meehl makes. In general, in the social sciences, if you're thinking about a relationship between two things, that's probably not going to be exactly 0. That relationship is probably going to be positive or negative. There may not be like a good reason for it, a good lawful reason. I mean, it's going to be lawful, but it's not like a theoretically interesting reason. Nevertheless, if you're looking at observational data, thinking about relationships between things, the null hypothesis that the relationship is exactly 0 is probably false most of the time. Paul Meehl uses the word CRUD to refer to these relationships. CRUD here means, they're there, they're truly non-zero in the population, but they're not theoretically interesting or important. So Paul Meehl argues that CRUD is a feature of most social science data. This is probably less true if you're dealing with randomized experiments, but it still may be true that CRUD is present in there, because it could be that most things that you could do in person have some small impact, even if it's small. So CRUD ends up being a real problem if you accept that it actually is present. for the default way of doing null hypothesis significance testing. So most of the time in the social sciences, when scientists use this method, they set the null hypothesis to be that some parameter of interest is zero, exactly zero. And the thing that they take as evidence for the theory, the thing that they want to be true, I suppose, is that that parameter is not zero. So once again, with this, you don't have to do null hypothesis significance testing this way. This is often the way social scientists do null hypothesis significance testing. They assume that some parameter is zero, that's the null hypothesis. And then the thing that they take as supportive of the theory is that it's not zero. Everybody home? So here's the problem. What I've plotted on the y-axis here is the value of a certain parameter. Let's say it's the relationship between depression and anxiety. So if you're taking, if you're using as the null hypothesis the idea that that relationship is zero, that's going to be represented by this red line. But I just talked about how, most of the time, especially in observational studies in the social sciences, most relationships are not going to be exactly zero. That's I don't know if that's true, but I think it might be a reasonable assumption in many cases. So most of the things that you look at are going to be non-zero in the population for reasons that are theoretically uninteresting. So let's just say that the level of CRUD in this relationship is, at that 0.3 range, or maybe it's 0.2, or it doesn't really matter, as long as it's not zero. One way of thinking about what you're doing if you're doing null hypothesis significance testing is that you gather, a sample of, say, 50 people. If you had done that over and over again, that you're going to get slightly different results every time. That's going to define a certain amount of sampling. And when you reject the null hypothesis, you're saying that you're confident beyond the level of sampling error that the null hypothesis is false. But the weird thing is that if there's CRUD in the relationship, you can choose whatever theory you like that makes whatever prediction you like. And if you increase your sample size enough, you're going to be able to reject the null hypothesis, not for an interesting reason, but due entirely to CRUD. The fact that there's just, in the social sciences, everything is more like So this is, this sets up kind of a paradox. So if you're taking the null hypothesis to be that there's a relationship of zero, if there is CRUD, then I'm going to be able to reject whatever hypothesis I like, that, or based on whatever theory I like. And it has nothing to do with the theory, nothing to do with its truth value. It's just due to CRUD. The other thing that's weird about this is that this is the idea that this is how this connects to testing disparities, as mentioned before. This problem gets worse and worse if you increase your sample size. So in effect, increasing your sample size has this weird effect of decreasing the testing disparity. And it has everything to do with what you define as the null hypothesis, and this idea that there's often going to be these quite relationships that screw up things. So there are actually tools that we can use to cope with this problem. It's not inevitable that we're faced with this paradox in the social sciences. So for one thing, if I am able to make my prediction, say that according to my theory, my effect is going to be large, where large means some value, so above 0.3. I can set that as my null hypothesis and then try to reject that null hypothesis. And if I do that, and the effect truly is, either 0 or a small value of what's caused by CRUD, then the more data I gather, the easier it's going to be to reject that hypothesis, the more severe my test is going to be. This is an equivalence test. We've talked about this before. So I'm setting the smallest effect that's substantively interesting to me, and I'm trying to reject the hypothesis that my effect is above that threshold. If I do reject it, I say that my effect is small and theoretically uninteresting. So even though this may be a problem in lots of areas of the social sciences, actually the tools are there to solve the problem. And I'll leave it up to you to think about the extent to which it's a problem in your application, because if you closely deal with randomized experiments, maybe this isn't a problem. But if you think it is a problem, well, you have the tools to deal with it. So, the second special feature that might be, one cause of the fact that in the social sciences our tests are really not severe, is this particular strategy of using the null hypothesis of no relationship and taking as evidence for your theory a rejection of the null hypothesis. So on Monday, I talked about one reason that's not ideal from a philosophy of science perspective. It's that there are lots and lots and lots of different kinds of relationships that could be counted as supportive of the theory. When in fact, what we want out of our tests is that they're severe, that they put our theory at risk, that we might actually reject the hypothesis if it's false. Another reason that the null of no relationship might be a problem has to do with this idea of CRUD. That most relationships dealing with people are going to be non-zero just because people are complicated. And like I said, we actually have some tools that might be useful for dealing with this problem as well. So one tool you can use is I try to make more specific predictions. Think about the smallest effect of substantive interest. Sometimes what's required to do that is formalizing your theories a little bit. So making them, working on their logical structure, trying to represent them using math, for example. So a whole area of formal modeling that deals with just this idea of turning verbal theories into something that's a little bit more logical and coherent. Not going to talk about that in this class, but the tools are out there. If you do have a theory that can make some sort of more specific prediction, think about that smallest effect of substantive interest. And I think that's something you can do even if your theory is not all that specific, because one way to set the smallest effective subset of interest is just thinking about, what resources do you have at your disposal? So am I able to collect enough participants, enough observations to get the precision necessary to get a really small effect? Or can I only investigate effects above 0.3? It's another way to do that. Another strategy that you can do involves using, a few of the tools that we talked about in the contrast unit. So I talked about this idea of representing your hypothesis using what I call the focal contrast. That's like a linear contrast or whatever it might be. And then testing whether the residual contrasts are small. Well, that's another way of looking for a more specific pattern that and ensuring that pattern actually holds in your groupings. So that's like one specific case study, one specific example of how you can use tools to make your test more severe. That's why I emphasize that, because if you can do that, that does represent a more severe test than, say, doing non-personal. One last thing you can do, it's pretty hard in the social sciences, but I've seen it done occasionally. And this is the strategy that people in physics use, is you try to make a very specific prediction. So the depression score in my intervention group is going to be exactly 3 on this 1 to 7 scale. If you can be that specific, and it's hard, there are many areas of the social sciences where we can do this. You can set that value of 3 as your null hypothesis and try to detect deviations from that value of 3. So if the value actually happens to be 4, or if it happens to be 2, that's what you're taking as a reputation of the theory. So a pretty cool way of doing this, instead of a null hypothesis of 0, you're setting it to a specific value and trying to reject it. Fits really well with this idea of severe testing. So if you can do it, that's super cool. I don't think it's usually possible. It's usually only possible if you have like a really formal theory that can give that prediction for you. But if you can do it, that's awesome. That's it. So, as I said, there's lots of writing about why things might be particularly difficult in the social sciences. People are complicated, and so there's just a lot that can go on. If you're interested in learning more about this, I really do recommend that you look up those papers by Coleman. This is the last day that I planned for the philosophy of science. So on Monday, we're going to start a new unit on logistic regression. That's analyzing models where you have a dichotomous outcome, a yes/no response, or a correct incorrect response. We're going to spend, I think, 2 weeks on that. I don't know exactly how much time it's going to take, so I'm going to be taking it a little bit by ear. But anyway, it's going to be a new unit. This stuff will come up on the next take-home at least a little bit, and also on the in-class. So I'm expecting you to know something about this. Although, you can probably guess, based on how much time we spend in class on these concepts, I'm going to expect you to know more or less. Anyway, thank you, and I'll see you all next week.
Yeah.